Pick Computer Science video number 5 is going to look at how we achieve iteration or looping with a little man computer. If we look at the instruction set, we're going to introduce a new instruction, which is instruction 6, or BR, which is to branch. And what branch means basically is go to a particular mailbox. So it sort of scuppers the program counter, overrides the program counter and says let's go to mailbox 13, for instance, if the instruction was 613. For the loop that we're going to write, we're also going to utilize instruction number 7, or BRZ, which is branch on 0. And that basically means only branch, only go to a particular mailbox if the result in the accumulator is 0. So we'll see how we utilize these two new instructions in a program. So here is our program in machine code. Notice we've got the instruction 6, we've got the instruction 7, our two types of branch. What our loop's going to do, if we were going to think about this loop as if it was a procedural piece of code, is we're going to accept some input from our user, an integer value. We're going to store that value in a variable, and whilst that value is greater or equal to 0, we're going to output it, we're going to print it. But within each iteration we're going to decrease our integer value by 1. That's what the minus there means. So eventually it will reach 0 and our loop will end. Here's what the assembly language might look like for this loop. So we're using 3 labels. One is to be able to store the value 1 in a mailbox, because we want to decrease our variable by 1 each time. Remember, it's a decreasing loop. So that's why that's stored there. And our other labels are used within our branching. You can see we branch on 0 to temp2. Temp2 is to output. We branch on any value, regardless of what it is, to temp3, which is also to output. So you'll want to study this code at some point, but let's see the program working. I've got the machine code for the loop loaded into the LMC. Notice the two new instructions, the two types of branching are in there. So let's run it and see what happens. First thing it's going to do is ask for some input. So this is the number, the integer that the loop is going to decrement and output the value of each time. So that goes into the accumulator. And the first thing it does is actually output that value. This time it's reading mailbox 2, which has the instruction 209 in, which means subtract. So 2 is subtract. The value from the accumulator that is stored in mailbox 9. So it's going to do 4 minus 1 and store that in the accumulator. Okay, so our 4 minus 1, 3 is now in the accumulator. Next thing it does is it branches on 0. This means it will go to mailbox 5 if the value in our accumulator is 0, which it isn't. So it won't go to mailbox 5. What it'll do instead is it'll go move on to mailbox 4, the next mailbox to be checked as far as the program counter is concerned. So it's checked the accumulator, it isn't 0, goes and gets the next mailbox to check, which is 4. 601 is just a simple branch instruction. So this means go to mailbox 1. So it's going to go back to here and it's going to repeat our process. So it's going to output first of all the value that's in the accumulator, which is 3. And outputs it. So it's quite a neat and clever way of decrementing our variable and outputting the value. So let's watch that happen a couple more times. Eventually our accumulator will have 0 in, and we'll hit this condition, this branch, which will say if it's 0, which it will be, go to mailbox 5, which is again just to output, so it'll output the 0, then it'll move on to mailbox 6, which is to halt. So let's watch that happen. So now our accumulator is 0. So it's hit the 705, as you jump to mailbox 5, outputs the 0, and our program halts. Success. It might seem a bit strange to have looked at iteration before selection, but we'll look at selection in the next video, and it might become clear why, although iteration might seem a more complex concept in procedural programming, it's maybe a more simpler concept than selection in the little man computer and assembly language and machine code.